Hi everyone, welcome back to our channel. Today we will revise past paper questions, all the questions that are related to chapter 2. Okay, let's start. Question 1. The diagram represents some elements, compounds and mixtures. So let's see this diagram. In the first picture, if you see here that there are different substances here, and each of them, if you see one of them, there are two different atoms joined together, which means it is a compound, right? So see which option is showing a word compound. Yeah, B and D is showing the word compound, so it means B or D can be right. Now let's see second. In the B and D, in the second one, if you see, they are still the compounds, right? But these two compounds are different, so it means it's a mixture of compounds actually. So let's see where the word in B or D we can find the mixture of compound. Yes, in B we have mixture of compound. It means option B is right. We can also see for the third option, you see elements. It is an element. Why? Because both the atoms in one molecule are same. So elements are made up of same molecule, same atom, right? And then this is the mixture of the elements. So option B is correct. Let's see question number 2. Which substance is a mixture? So air, graphite, oxygen, and water. All of these are compounds. Either they are compounds or they are the element, right? Graphite is an element, oxygen is an element, water is a compound. Only air is a mixture of gases. So option A is right. Question number 3. Which statement about clean, dry air are correct? It is a mixture of elements only. No, that's wrong because it contains oxygen. It also contains carbon dioxide, and carbon dioxide is a compound, right? So let's see now option number 2. It's a mixture of element and compounds. Yes, that is correct. And number 3, it contains only non-metal. That is wrong. So it's actually made up of the elements and compounds. So option number 2 is right. D. Yes. Okay, which row about elements, mixtures, and compounds is correct? So let's see which row about the elements, mixture, and compound is correct. Metallic elements, let's see. Copper, brass, they all are metallic elements. Yeah, we know. Okay, let's see non-metallic elements. Methane, sulfur, methane. Methane is actually a compound. It's not an element. So that's wrong. So we are left only with the option B or C, right? So sulfur is right because sulfur is a non-metallic element. Now let's come toward the mixture. So brass is actually a mixture of the two metals, right? So brass is actually the mixture. Copper is a pure element, so we cannot say that copper is a mixture. So this option number C, copper, sulfur, brass, and then compound. Of course, methane is made up of carbon and hydrogen, so it's a compound. So option number C is right. Question number 5, which equation represent a chemical change? So now let's see these all equations one by one. First, if you see BaCl2 is converted into BaCl2, but it is solid and then it is changed to liquid. So only the state has been changed, which means that is a physical change, right? So that option is incorrect. Now let's see for option number 2. Calcium ions are reacting with sulfate ions, and if you see this one, they both were aqueous and now it become a precipitate. So this reaction is showing actually a chemical change. So option B is right. Why option C is not right? If you can see here that potassium chloride is dissolved in the water and it is forming the ions. So usually it's a physical change, right? Because whenever you dissolve any salt in the water, it is a physical change. And then sodium and nitrate, they are reacting. But the sodium nitrate, the one which is formed, is actually still an aqueous solution. It's not a solid like this, the option B. So that's why option D is not correct. It's still in the form of ions in the aqueous solution. So there is no change. Okay, so option B is correct. Question number 6, which statement about the position of the element in the periodic table are correct? So let's see, element in the same group have similar chemical properties. Yes, that's right. They have similar because they are using the word similar because they have outer shell electrons. They are same in the same group. So that's why it's right. Element in the same period have similar chemical properties. No, it's wrong because in the same period you can have metals and also have non-metals, right? So question number 3, elements in the same group have the same number of electron shells. So if they are in the same group, then group always define the number of outer shell electrons, but they are talking about the electron shell. That's wrong, right? So option number 4, element in the same group have the same number of outer shell electron. Yes, that's right. Group always represent the outer shell electrons and period always represent the electron shells, right? So option number 4 is right and 1 is right. So it means B option is correct. Question number 7. Iodine has a lower relative atomic mass than tellurium. but it is placed after it in the periodic table. Which statement explains why iodine is placed after tellurium in the periodic table? So we already know that in periodic table, the elements are arranged according to their atomic number, not according to their atomic mass. Okay. So what is atomic number? Actually, it is a proton number. So if you see any option for the proton, let's see. Yeah, option number D. Can you see here that iodine has more protons than tellurium? Yeah, that's why it is after tellurium. So that's why option D is correct. Question number 8, 4 statements about the atoms are listed. The center of an atom is positively charged. Yes, that's right. The center of an atom is nucleus and it has protons, right? So it is a positive charge. Protons and electrons are located in the nucleus. That's wrong. Only protons and neutrons are located. Electrons are not. So option 2 is incorrect. Proton and electrons have the same mass. That is wrong. Protons have AMU one AMU mass, whereas electrons don't have a negligible. They have almost a negligible mass, right? So most of the mass of an atom is in the nucleus. Yes, that's right, because protons and neutrons are in the nucleus. So that's why most of the mass is in the nucleus. So option 4 is right and option 1 is right. So it means B option is correct. How many electrons are shared in one molecule of nitrogen and in one molecule of ethane? So for this one, you have to look at your periodic table. And if you see the nitrogen usually is in the form of diatomic molecule, it means it is present in the form of N2, right? So N2, it usually make 3 bonds. So 3 bonds means 3 covalent bonds means it will share 3 pairs of electrons, right? So 3 2s are 6. So it means nitrogen will share 6 electrons. So C or D can be right. Now let's see for the ethene. In ethene, the formula of ethene is C2H4. So we have 2 carbon and we have 4 hydrogen. So 4 hydrogen will share 1 electron each. And carbon, because its valency is 4, the last shell electrons, so it will share 4 electrons. So 2 carbon will share 8 electrons, and then we have 4 hydrogens. So 8 plus 4 is 12. So option C is right. Okay, question number 10. Nitrogen forms a nitride ion with the formula N3 minus. Which particle does not have the same electronic configuration as the nitride ion? So for this one, you have to open your periodic table. So first of all, let's see for aluminium. Aluminium is 3 plus. So aluminium has total 13 electrons. So if it loses 3 electrons, as it's shown here, that it has a 3 positive charge. So it means now it's what will be the electronic configuration? It will have only 10 electrons left, right? But in N3 minus, if you see, N has 7 electrons total and 3 it will gain more. So how many it will get now? It will get 3 more, so it will become 10, right? So nitrogen and aluminium have same electronic configuration. Let's come toward chlorine now. Chlorine has 17 electrons in its outer shell. So if it gains 1 more electron, it will become 18. So it will be it will have 18 electrons. But if you see, nitrogen has only 10 electrons. So it means option B is right. Chlorine don't have the same electronic configuration as the nitride ion. You don't need to look for the sodium and oxygen because we already find the chlorine option. So question number 11, the atomic structure of 4 particles, W, X, Y, and Z are shown here. Which particles are isotopes of the same element? So now, what are isotopes? Isotopes are actually the atoms of the same element. They have same number of protons, same number of electrons, but only the number of neutrons are changed, right? So let's see over here, which one of them have same number of protons. If you see over here, W and Y have same number of protons, right? And X and Z has same number of protons. So we already know that proton is always equal to electron number. So if you have 2 protons, then electron number should also be 2. So that's right. So if you have 3 protons, then electron number should also be 3. That's wrong. So X is not an option. Let's see for this one, Y. 2 protons, 2 electrons. Yes, that's right. So now W and Y are actually, they have the same number of electrons and same number of protons, but only the neutron numbers are different. So it means they are actually the isotopes, W and Y. So option B is correct. Question number 12, the diagram shows the part of the periodic table which element is correctly matched with its electronic structure. So for this, you have to look at your periodic table. So the A is actually lithium. It has 3 electrons. So 3 means the first shell will have 2 electrons and the second one will have 1. So 2, 1, but that's not here. So it means A option is wrong. Now let's come toward B. So what is B? Actually, it is nitrogen. So nitrogen should have 2 electron in the first shell, and then we have 5 electron in the second shell. But if you see here, it is 2, 4. That's also wrong. Now let's come towards C. So what is C? It is actually magnesium. So magnesium has total 12 electrons. And if you see over here, 2 in the first shell, second shell have 8 electrons, 10, and then again we have 2 electrons. So total 12. So I think, so that's why the option C is correct. It's magnesium, right? The C is correct. Which diagram represent one helium atom? And these are the key points here, that protons are the black circles, neutrons are white circles, and gray circles are electrons. So we already know that electrons are always present in the outer shell, right? So we will see where is the outer shell in which we have electrons. Yeah, we have electrons over here. We have also electrons here. But here it is proton, that is wrong. Here we have neutron, that is also wrong. Now see, the protons are also outside here, right? But it is wrong because protons are always in the nucleus. So it means only we are left with the option B, because proton and neutron both are in the nucleus, right? So option B is correct. Let's see question number 14. The structure of an atom is shown here. Which element is the atom an isotope of? So if you see over here, you have to just see the electron number. And if you count them, 1, 2, 3, 4, 5, 6, 7, we have 7 electrons. And which one has the 7 electrons? It's nitrogen, right? Because the proton number is always equal to electrons. So option A is correct. Question number 15. The structure of an atom of an element X is shown over here. Which element is X? So you have to count again the electron numbers 1, 2, 3, 4, 5. So 5 electrons are present. This is boron, because boron has 5 electrons and 5 protons, right? So the atomic number of boron is 5. So it is A. Again, we have A option. Now let's see question number 16. What do the nuclei of hydrogen atom contain? So if you see this one, it has atomic number 1. The atomic number is also 1 and the mass is also 1. So we already know that atomic number is equal to the proton number. So if you see the mass number is 1, it means that in the nucleus we just have the proton there that has the mass 1, right? We have no neutrons, because if we have neutrons, then it should not be 1. But the proton number, the atomic number and atomic mass is same. It means we have only proton present in the hydrogen. So it means option D is right. Hydrogen, in this isotope of hydrogen, we have only protons, okay, in the nucleus. Question number 17. An atom has 3 electron shells. There are 3 electrons in the outer shell. So if you see, they are already telling you that we have 3 electron shells, okay? And there are 3 electrons in the outer shell. So total we have 3 electrons. So in the first shell, we always have 2 electrons, right? In the second shell, the maximum electrons can be 8. So how many electrons now we have? Total 10. And in the third shell, they already have told you that we have 3 electrons. So 10 plus 3 is 13, right? So total we have 13 electrons in this atom. So if the number of the electron is 13, then it means the number of the protons will also be 13. They are always equal. So it means option A or B can be right. Now let's come toward the neutrons. You don't have to look in the periodic table even, but if you want to try, you can see that which one has aluminium. Aluminium has 13 electrons. So the neutrons will be, its mass is 27. So 27 minus 13 is 14. So it has 14 neutrons. So that's option A is right. But even if you don't want to look at the periodic table, you need to remember that neutron number is just 1 or 2 number more than that of the protons. So because this is 27, right? It is quite like double of that of the proton. So that's wrong. So 14 is right. So A option is correct. Question number 18. Element X has 7 protons. Element Y has 8 more protons than X. So now let's see which element is X. So 7 protons, if you see in the periodic table, it's nitrogen, okay? And now we have another element that has 8 more protons than X. So let's see which element is that. 7 plus 8 is 15. So we have to see phosphorus, okay? So phosphorus, and this one is nitrogen, and this one is phosphorus. Now let's see which statement about the element Y is correct. So element Y is actually phosphorus. Y has more electron shells than X is right. Why? Because if you see, phosphorus is in the other periodic table, right? Is in the other period, is in the third period. But nitrogen is in the first period. Y has more electron in its outer shell than X. That's wrong because they both belong to the same group. If you see nitrogen and phosphorus both belong to group 5. So it means they have 5 electrons in their last shells. Y is in different group of the periodic table. That's wrong. You can see in your periodic table, nitrogen and phosphorus are in the same group. Y is in the same period of the periodic table. That is also wrong. They are not in the same period. So it means we are only left with option A. So option A is correct. Question 19. The electronic configuration of two elements are given, element L 2881 and then element M 284. So if you see here, they now want to know that which group number or period number they belong to. Okay, so group number always tell you the last shell electrons. So if you see for element L, how many electrons are in the last shell? Only one, right? So it means it belongs to group 1. And how many shells it have, it will decided by the period number. So if you count the shell number 1, 2, 3, 4, so it means it has total 4 shells. So it belongs to period number 4. So option A is right? And option B is also right. So let's see now for element M. Element M is 284. So it means it has total 3 shells. Or 3 shells means that it has the period number 3. So which has the period number 3? Of course, option A. So it means option A is right. And even if you want to see the group number tell you the last shell electrons. How many electrons we have in the last shell? 4. So it means the group number 4 is, this option A is right. Question number 20. An atom of element R contains 15 protons, 16 neutrons, and 15 electrons. What is R? So just because the proton number is actually the atomic number, you just have to find which one has the atomic number 15. So let's see which one has the atomic number 15 in our periodic table. It's phosphorus. So phosphorus has 15 electrons, yeah. So that's why the atomic number is 15. So it has 15 protons and 15 electrons. So the option B is correct. Phosphorus is the right answer. The nucleus of a particular atom consists of 19 particles. 9 of them are, so now these 19 particles are in the nucleus. What does it mean? It means we have protons and neutrons. We are talking about the protons and neutrons. 9 of them are positively charged. So which of them are positively charged? Of course, protons. Neutrons have no charge, right? So 10 of them are neutrons. So which statement about this nucleus is correct? The nucleus has a nucleon number of 9. That is wrong. Nucleon number and the mass number is same. Nucleon means proton plus neutron. So the nucleon number is actually 19. Okay, so this option is wrong. The nucleus has a nucleon number of 10. That is again wrong because it is 19. Okay, the nucleus has a proton number of 9. Yes, that's right, because the positive charge particles we have are 9. So option C is correct. Question number 22. How many protons, neutrons, and electrons are there in one atom of isotope of aluminium? So if you see, the smaller number always tell you the atomic number. And what is atomic number? It is actually the proton number. So 13, where we can find 13 in A and B. So it means A and B option can be right. So now let's see for the electrons. Electron number is always equal to proton number. So it's also same in both A and B. Now we are only left with the neutron. So 27 is the atomic mass, and atomic mass is equal to proton plus neutron. So 27 minus 13 will be 14. So it means option B is correct. We have total 14 neutrons in aluminium and 13 electrons and 13 protons. So option B is correct. Let's see question number 23. What is the total number of electrons in one molecule of ammonia NH3? So if you see nitrogen has 7 electrons. Hydrogen, we have 3. So 3, each hydrogen has 1 electron. So total 3 and 7. 7 plus 3 is equal to 10. So option C is right. Question number 24. Which statement about a phosphorus atom P3115 are correct? The nucleon number is 16. Again, it's wrong. The nucleon number is actually the atomic mass, and the bigger one is the atomic mass, that is 31, right? The number of outer electron is 5. How we will know? We can see from 15. 15 is the proton number. Proton number is equal to electron number, right? So in the first shell, if we have 2 electrons, in the second shell, we have 8 electrons. So total 10, and now we are left with 5 electrons, right? So in the third shell, we will have 5 electrons, and third shell is the outer shell, right? So outer electrons are 5, that is right. The proton number is 15. Yes, that is also right. So option 2 and 3 are correct. So where we can see option 2 and 3? Option number D. So option D is right. Question number 25. The atomic structure of 4 particles are shown here. PQRS. Which particles have the same chemical properties? Now only those particles will have same properties which have same number of electrons. So if you have same number of electrons, it means the proton number should also be equal to the electron. So if you see here, which one of them? PQ has 18 electrons, right? And RS has 17 electrons. So it means these two are isotopes, or these two can be the isotopes. Now let's see for the proton number. Electron and proton number should be equal, but they are not, right? So PQ is rejected, RS are left. Now we are only left with RS. And the neutrons are different. That's okay because they are the isotopes. So it means R and S is the right option, option D. Question number 26, a representation of an atom is shown over here. What is the nucleon number of this atom? So what is the nucleon number? These all particles which you can see inside the nucleus is actually the nucleon number. So we can count them and we can see that actually we have 1, 2, 3, 4, 5, 6, 7 neutrons and 6 protons. So 6 plus 7 is 13. So option D is right. Question number 27. The table shows the structure of different atoms and ions. What are the values of W, X, Y, and Z? Let's see for W. So the number of neutrons we have to find. We know the number of protons. We know the number of the nucleon. So 24 minus 12 is 12. So W value is 12. So where we can find 12? Yeah, so it means only option C or D can be right. Now let's come toward Mg2 plus. So the proton number we have to find. If you see the proton number, the number of proton is already given here again. So it should be same, right? The proton number, they just want to confuse you, but it's same. Okay, so 12 and 12. So it will be 12. So where you can find the 12? Yes, in option D. Okay, now let's see for fluorine, why? So the number of neutrons, how many neutrons we can have? Nucleon number is 19. Proton will be 9. So 19 minus 9 is 10. Yeah, of course. So D is the right option. 12, 12, 10, 10. So D, you don't need to find for the Z. You can save your time because you already have find that these three options are correct. Question number 28. The table shows the information about the atoms of three different elements. Again, now we have the same question like before. So what are the value of W, X, Y, and Z? Now let's see for W, the number of neutrons we have to find. So nucleon number, we already know proton. So nucleon is equal to proton plus neutron. Okay, so now nucleon 35 minus 17 is equal to 18. So 18 is the right answer for W. So A or B option can be correct. Now let's see for the chlorine. Nucleon number X. So how we can find the nucleon number? The number of protons plus the number of the neutrons, right? So 17 plus 19 is equal to 36. So which option has 36? Of course, option B. So we don't need to count for the remaining one. Of course, the option B is correct, okay? You can save your time. But even if you want to try, you can try for Y and Z also. Question 29. The table shows information about 4 different particles. Same question, so but different particles now. So we have to find the value for W, number of neutrons. Always number of neutrons is and number of protons is equal to nucleon number. So nucleon 23 minus 11 is equal to 12. W is 12. Oh, C and D option can be right. Now let's see for sodium. Sodium, we have to find the number of electrons. So if you see the number of electrons is always equal to number of protons, right? So it should be 11. But if you see the sodium has a charge now, which means a positive charge means it loses 1 electron already. So if it has 11 electrons, now we are left with only 10 electrons, right? So 10 is the right option. So which one has the 10? We can see over here option number C has 10. So it means option C is right. But we can see for oxygen also the number of neutrons, 16 minus 8 is 8. Yes, so option we have still 8. And then even if we see over here, the number of electrons in oxygen will be how much? It should be 10. Why 10? Because it has number of protons 8. So the number of electrons should also be 8. But if you see the charge is 2, negative 2, right? So it means it gains 2 more electrons. So 8 plus 2 is equal to 10. So which option is right? Option C is correct, okay? Question number 30. Which 2 particles have the same electronic structure? So if you see the electronic structure of all these, you have to see your periodic tables. So carbon has 6 electrons, and if you see oxygen, if oxygen gains 2 electrons, it will become 10. So they are not same. Now let's come toward fluorine. Fluorine has 9 electrons. So when fluorine will gain one more electron, it will become 10, right? The electrons will become 10. And what about the sodium? Sodium has 11 electrons. So they are also not the same. Now let's come toward the potassium. Potassium has total 19 electrons. Okay, so if it lose one electron, it will become 18, right? Now let's come towards sulfur. So sulfur has how many electrons? 16. So when sulfur has 16 electrons and it gains two more electrons, it will become 18. So same like potassium. Potassium is also 18. Sulfur also have 18 electrons now, these ions. So option C is correct. Question number 31. The diagram shows the electronic structure of a particle with a nucleon number of 40. Okay, you can see over here the nucleon number is 40 and we have also the electrons. The table shows the suggestion that 3 students 1, 2 and 3 made to identify the particles. So which students are correct? Now let's see which particles have 40 atomic mass. So if you see argon has the mass 40 and also calcium also have the mass 40, okay, right? So now let's see about the number of the electrons, how many it has. So if you see 1, 2, and then 8, 10, and then 11, 12, 13, 14, 15, 16, and 17, 18, okay? So argon has 18 electrons. So argon option is right. Then if you see for calcium, if lose 2 electrons, then it will also become 18, right? So argon and calcium is right. Why not chlorine? Because chlorine has 17 electrons, right? And if you see here, we have 18 electrons here. So option 2 is wrong. 1 and 3 are right. So where is 1 and 3? Option B. Option B is correct. Let's see question number 32. Which statement about an atom of fluorine is correct? So it contains a total of 28 protons, neutrons, and electrons. So if you count, these are the proton and neutron, and proton and neutron, and and this is proton, right? So proton is equal to electrons. So if our mass is 19, then how many, like we have 19 proton, neutron, and then if you add 9 more, that is electrons. So how many it will be total? 28. So option A is right, but you can still see option B. It contains more proton than neutrons. That's strong. If you see 9 is proton, so 10 is actually neutrons. So neutrons are more. Its isotope contain different number of proton. That is wrong. Isotopes always have same protons. Only the neutron number is different. Its nucleus contain 9 neutrons. That's strong because 9 is actually the proton number. So 10 is actually the neutron number. So we are only left with option A. So option A is right. Some information about particles P, Q, R, and S is shown over here. So which two particles are isotopes of the same element? So the first thing about the isotopes is that the isotopes of the same element will always have the same number of the proton, right? Same number of proton means the proton number is always equal to electron also. So if you see which one of them have same number of electrons, P and S have same number of electrons. Q and R have same number of electrons, right? So when the number of protons, electrons, we already know, right? So now the electron number is always equal to the proton number. So our proton number should also be same, right? So how we can calculate this one? How we can find the proton number? We already know that proton plus neutron is equal to nucleon. So if you minus 12 minus 6, your answer should be 6, right? So it has 6 proton. So 6 proton is also equal to 6 electron. That means P is right. Okay. So let's see for S now. 14 minus 8. What you will get? 6, right? So again, we have 6 number of proton and 6 number of electrons. So it means the P and S are actually the isotopes of each other. But if you see here, 24 minus 12 is 12, which means it has 12 proton. And we have how many electrons? 10. So 12 and 10 are not equal. So that's why Q and R option is rejected. P and S is the right option, option B. Question 34. The number of protons and neutrons and the electronic structure of 4 particles W, X, Y, and Z are shown here. Which particles have the same chemical properties? So the chemical properties of any particle will depend on the electron number. Always remember that protons are not involved in chemical reaction. These are actually the electrons that are involved in chemical reaction. They are the ones that are making the compounds, or they are making the molecules, or the covalent bonds, ionic bonds, right? So you have to, whenever they are asking about the chemical properties, you have to remember the word electron. Okay. So let's see the proton number. No, we don't have to look. Don't have to look for the neutrons. Let's look just for the electronic structure, because these are actually the electrons. So if they have same chemical properties, it means they should have same number of electrons, right? So let's see which one of them has same number of electrons. 2, 8, 2, 6, 2, 6, 2, 8. So it means XY has same, right? And also W and Z have the same number of the electronic structure. But now let's come toward now proton number. So our proton number should also be same to that of our electron number. So our electron number is 8 over here, right? So it means our proton number is also 8. But if you see here, the electron number is 10, but proton number is not 10. So it means it's wrong. So only option, which option is now right? This option, 2626, and then we have same number of protons. So proton and electrons are same over here, X and Y. So option C is correct. Question number 35. How many neutrons are present in the atom? This. So the smallest number always indicates atomic number. What is atomic number? It's actually the proton number, right? And the bigger number will always indicate the nucleon number. What is nucleon number? It's the proton plus neutrons. So proton, we already know 21. So if you minus 21 from 45, what will you be left with? 24, right? So 24 is the neutron number. It's simple. Question number 36. Which element does not form a stable ion with the same electronic structure as argon? So now let's see what argon has. How many electrons it has? It has 18. Now, if you see aluminium has 13 electrons, right? So even if aluminium lose 3 electrons, it cannot make 18, right? It will become 10. But usually aluminium make covalent bonds. So it will share the electrons. So it means our aluminium is the right answer. But if you are confused, you can just see for option B, C, and D. Let's see for chlorine. So if chlorine make an ion, chlorine is 17, right? So it will take 1 electron and it will become 18. Argon is also 18. So it means chlorine is right. Phosphorus has 15 electrons. So it belongs to group 5. So it will usually take 3 electrons. So when it takes 3 electrons, it will also become 18. Same potassium has 19 electrons and is a metal, so it will lose 1 electron. When it will lose 1 electron, it will also become 18. It will have 18 electrons. So all these three will have 18 electrons, same like argon. So it means only aluminium is the one that cannot make stable ions, same like argon. So option A is right. Question 37. Which two molecules contain the same number of electrons? So now for this, we have to calculate all these, and you have to see for chlorine have 17. So 217 is 34, right? Same you can calculate for SO2, then you can calculate for CH4 and H2O. as 6, H is 4, so 10, and hydrogen 2, and oxygen is 8. So this is also 10, so option B is correct. But you can calculate for all of them, and then you can find that option B will be right. The other one, they don't have the same number of electrons. Question 38. The atomic number and nucleon number of a potassium atom are shown over here. Okay, how many protons, neutrons, and electrons are in potassium ion? Okay, so if you see the atomic number is 19, what does it mean? It means the proton number will be 19. Can you see any proton number that is 19? Yes, A and B. So it means the option A or B is right. Now let's see for the neutron numbers. So 39 minus 19 is how much? 20. So the neutron number is 20. Okay, option B is still right. A and B both are right. Now let's come toward electrons. Proton number is always equal to electrons, right? So it should be 19. But we are talking about potassium ion, and if you see the charge is +1, what does it mean? It means it lose 1 electron. So if it lose 1 electron, so 19 minus 1 is 18. So it should have 18 electrons now, right? So option A is correct. Let's see question number 39. An atom of element X contains 5 protons, 6 neutrons, 5 electrons. Which statement about element X are correct? X has atomic number of 6. No, it has atomic number of 5 because it has 5 protons, right? So that's wrong. X has a nucleon number of 11. If you nucleon number means proton plus neutron. So 5, 6 is 11. Yes, option 2 is right. X is in group 2 of the periodic table. That we have to see now. How many electrons it has actually? 5 electrons, right? So the first shell can have only 2 electrons. So how many left? We are left with the electrons? 3. Second shell can have at maximum 8 electrons, right? So the first shell will have 2 and then the second shell will have 3 electrons. So we are done. So it means it has 2 shells. And if it belongs to 2 shells, so X is in group 2 of the periodic table. Is it right? No. It is actually in the group 3 of the periodic table. Okay, so option 2 is only right. X is in the second period of the periodic table. Why in the second? Yes, that's right, because if you count, the first shell has 2 electrons and the second shell have 3 electrons, right? So it means we have 2 shells total in number, and the shell number is defined by the period number. So second period, so 2 and 4 option is right. Okay, 2 and 4 is option D. So option D is correct. Question number 40. An element S has the proton number 18. The next element in the periodic table is an element T. So if you see in the periodic table, you have to open your periodic table. Which one has 18? Okay, it's argon. Okay, so argon is 18. So the next one is potassium. So now which statement is correct about potassium? Element T has one more electron in its outer shell than element S. Element T has one more electron, but not in its outer shell. Okay, because in the outer shell of argon, we have 8 electrons because it belongs to group 8, but potassium belongs to group 1. It has only 1 electron. So it means this statement is wrong. Element T has one more electron shell than element S. Yes, that's right. Because if you see argon belong to group period 3, it has 3 shells, but potassium belong to period 4, so it has 4 shells. So option B is right. You can see state option C, element T is in the same group. No, they are not in the same group. Potassium is in group 1, argon is in group 8. Element T is in the same period. That is also wrong. Element T is in the 4th period. And element S, which is argon, it is in the 3rd period. Okay, so option D is correct. Question 41. 2 atoms X and Y have the same mass number, but different atomic number. Which statement about X and Y is correct? So now let's see, if they have different atomic numbers, it means they have different number of protons. So first option is rejected. Second, they have same number of electrons. That's also wrong because proton number is always equal to electron number. If atomic number is not same, it means the electron number is also not same. They are in the same group of the periodic table. That is still a tricky. We are not sure if they have different atomic number, then they cannot be in the same group of the periodic table. It's possible. Okay, so they have different number of neutrons. Yes, neutrons. Yes, that is possible. If you see, the example is already given in your book, in your periodic table. Argon and calcium, they both have same mass number, but their atomic mass is okay. Their atomic number is different. So if you see, they are not in the same group of the periodic table, but they have different number of neutrons. Why the number of neutrons are different? Because the proton numbers are different, right? So when the proton numbers are different, of course, the neutron number will also be different. That's why you are getting the same mass number. Okay, so option D is right. You can even try to calculate it. Try different calculations and you will see that the 2 different neutron numbers and 2 different atomic numbers can give you the same mass number. Question 42. Particle P has an atomic number of 18, a mass number of 40, and no overall charge. It means it's an atom, okay? It's not an ion, it's just an atom. So particle Q has an atomic number of 19, a mass number of 40, and a single positive charge. Okay. So now the mass number is same, but their atomic numbers are actually different, right? And they have a positive charge. So which statement is correct? First, they are isotopes of the same element. Their atomic number is different, right? So they cannot be isotopes of the same element. because it has a positive charge. What does it mean? It means its atomic number was 20 before, right? And it lose one electron. So they are not the isotopes of the same element because their atomic number is not same. They are both ions. No, one has no charge, the other one has charge. So one is ion, but other one is an atom. Q has more neutrons than P. So yes, that can be right, that Q has more neutrons than the P. Because if you see over here, the atomic mass was 20 and still we are getting 40. So this can be right. They have the same number of electrons in their outer shell. No, one is 18, the other one is 19. So they cannot have the same number of electrons in the outer shell. So option C is the only left option. So that's right. Question 43. X and Y are two different elements. X and Y have the same number of nucleons. Which statement about X and Y is correct? So they are two different elements, but they are nucleon. What does it mean? It means the mass number is same, right? So they have the same physical properties. No, that's not right because they are not the same elements, right? So we are not sure that how can they have the same physical properties. Did atoms have the same number of electrons? No, it's not right because they are different elements. So they cannot have the same number of electrons. They can have, because the proton number will not be same, so electron number, of course, will not be the same. They are in different groups of the periodic table. So they can be in the different groups of the periodic table. That is right, because they have the different number of the different elements, right? So they can have different number of electrons. So that option is correct. They have different relative masses. That's wrong because we already have discussed here that the same number, they have the same number of nucleons, which means the relative mass will be same. So option C is only the right option. Question number 42. Which statement describe isotopes? So isotopes are the atoms of the same element that have the same proton number, but they have different neutron number. Okay, the neutron number will be different. Now let's see. Isotope of the same element has different electron arrangement. That's wrong. Okay, because the proton number is same, so that's why electron number is also same. Isotope of the same element have different nuclear charges. That is also wrong because the proton and neutron and electron number is same, right? Proton and electron number is same. They are the charged particles. So the nuclear charge will also, the nuclear charge is positive. Proton number is same. So the nuclear charge is positive, so it will remain the same. Isotope of the same element have nuclei with the masses that are the same. That is wrong because the neutron number is different. So when the neutron number will be different and it is in the nucleus. So what will happen? Actually, the mass will be different. Atomic number will remain same, but the mass number will be different. So now we are left with only option D. So option D is correct because isotopes of the same element have the same number of protons. Okay. Question 45. Which statement about the atoms of all the isotopes of carbon is correct? They all are radioactive. That's wrong because the simple carbon-12 is not a radioactive. They all have the same mass. No, because isotopes of the same element don't have the same mass, but they have the same atomic number. Okay, they have the same number of neutrons. No, it's wrong because isotopes only differ in the number of neutrons. Electron and proton numbers are always same. So that option is also wrong. They have the same number of electrons in the outer shell. Yes, that's right, because the proton number is same. So electron number will also be same. When the electron number will be same, so the arrangement will also be same. Okay, so option D is correct. Question 46. Which statement about isotopes of the same element is correct? They have different number of electrons. That's wrong. Again, they have different number of neutrons. Yes, that's right. Because isotopes always have different number of neutrons. Okay, they have different number of protons. Wrong. They have the same mass number. Wrong. So option B is the only right option. Question 47. X and Y are both atoms. X and Y have the same chemical properties as each other. Which row describe the atomic structure of X and Y? So if you see here, they already have given you the information that they have same chemical properties. So it means they are the atoms of the same element, right? So if the atoms of the same element, then it means they should have same proton number and same electron number. So now let's see which have the same proton number. X, option A. If you see, proton number, neutron, this is all proton number is equal to proton number, yes, and the electron number is not equal. That's wrong. So proton number is equal to this one, and also electron number is equal to this one. So that is right. So this one, Okay, not right. Because 6, this is 16. This is 7, this is 6, this is 7, this is 7. So only we are left with option number B because proton and electrons are same, right? 6 protons, 6 electrons. Also, we have here 6 protons and 6 electrons. Only the neutron number is different. So option B is right. Question 48. Which statement about the isotopes of an element is correct? Let's see which options are correct. Their physical properties are different because they have different proton numbers. Yes, the isotopes have different physical properties, but it's not because they have different proton numbers. They have same proton numbers, only the neutron number is different. The mass number is different because of neutron number. So because of the mass number, their physical properties are different, right? So option A is wrong. B, their atomic mass are different. Atomic masses are different because they have different number of electron shells. That's also wrong. Electron shell number is also same. They have the same chemical properties because they have the same number of electrons in their outer shell. Yes, they have same chemical properties because they have same number of electrons. Okay, option C is right. Question 49. Which statement about isotopes of the same element are correct? Again, so same question can be repeated. They can give you different types of the option and you have to find the correct options. So first, they are the atoms that have same chemical properties. Yes, that's right. Because they have the same number of electrons in the outer shell. Yes, that's right. Because the chemical properties depend on the electrons in the outer shell. So option 1 is correct. They have the atoms which have the same number of electrons and neutrons. You see, neutrons. No, that's wrong. Isotopes don't have same number of neutrons. So this rejected. They are the atoms which have the same number of electrons and protons, but different number of neutrons. Yes, that's right. That is actually the definition of isotopes, that atoms have the same number of electrons and protons, but different number of neutrons. So option 1 and 3 is right, and that is B. So option B is correct. Question number 50. Which statements about isotopes are correct? See, we again came with the same question, but there are different options here. So that's why I have added all the questions from the past paper that are related to isotopes. So you can see that the question will remain the same, but the option can differ. Okay. So if you see here now, which statement about isotopes are correct? Isotopes are the atoms of different elements with the same number of protons. Same number of protons is right, but if you see isotopes are the atoms of different elements, that's wrong. They are the atoms of the same element. Okay? So option 1 is wrong. Isotopes of the same element have the same chemical properties. Yes, that's right. Isotopes are atoms with the same relative atomic mass. Wrong, because the relative atomic mass depend on neutron and proton, and neutron number is actually changing in isotopes. So option 3 is wrong. Isotopes of the same element have same electronic configuration. Right, because in isotopes, there will be no change in the proton and electrons, right? So option 4 is right. Option 2 is right. So it means option number C is right. Question 51. The number of protons, neutrons, and electrons present in the atom PQRS are shown here, okay? So which atoms are the isotopes of the same element? So now again, we have to see the number of the protons and the number of electrons should be same, right? So if you see the number of proton, number of electron is 4, 4. So do we have anyone that has 4, 4? No. So now we are just left with this one, R and S, right? R has the number of protons and electrons same. And S also have 6 protons and 6 electrons, right? So R and S is the only option we are left with. So option C is correct. Question 52. X and Y are the atoms. X and Y have the same number of electron shells. They have same number of outer electrons. X and Y have different mass number. So if these two things are same, it means they are the isotopes, right? Only the mass number is different, it means the neutron number is different. So which statement about X and Y are correct? They are the isotopes. Yes, that's right. Why isotopes? Because they have different mass numbers, but they have the same electron number, right? It means the proton number is also same. X and Y have the same total number of electrons. Yes, right, because they already have told you same number of electron shells and same number of outer electrons even. So it means same number of electrons. X and Y have the same chemical properties, right? Because the electron numbers and also the outer electrons are same. So it means all these options are correct. So 1, 2, and 3, option A is correct. Question 53. What is an isotope of E? So if you see, this is the mass number, and the smaller one is always the atomic number. So atomic number should always be same for all the isotopes. So if you can see which one has 15. So option B, only option B has 15. So it's mean option B is right. Chlorine exists as two common isotopes, Cl35 and Cl37. Information about these two isotopes are shown. Which statement explain why the two isotopes are of the same element? Okay. So what defines an isotope? Isotope of an element always had the same proton number because they are of the same element. And what thing decide that this atom belongs to the same element? Actually, it's proton number. Okay, so what is the right answer? Both have the same number of electron shells. Yes, that's right. But we are asking about the same element. Which thing decide that they belong to same element? That is actually the proton will decide, because proton number never change. Electron number can change because sometimes the atoms can lose electron, they can gain electrons, so they can have more electrons, or sometimes they have less electrons, right? But proton number never changes. So that's why the number, they have the same number of proton. This is actually deciding that both isotopes belong to the same element. Okay, because the elements are actually decided on the base of their proton number. Question 55. There are two stable isotopes of bromine. One is 79, the other one is 81. So which statement is correct? The isotopes have the same number of neutrons. Wrong. Isotopes never have the same number of neutrons. The isotope have different chemical properties. Wrong. Isotopes always have same chemical properties. The isotope have different number of protons. Wrong. They have same number of electrons and protons. The isotopes have the same number of outer electrons. Yes, that's right. Because the isotopes always have same number of electrons, so outer electrons will also be same. So option D is correct. Question 56. Which pair shows the particle with the same chemical properties? So same chemical properties, they should have same number of electrons, right? Electrons. So if the electron number is same, then of course they will have the same number of the will have the same properties. So now let's see which one has the same number of electrons. If you see here, they have the same number of protons, right? So proton number is equal to electron number. So this one has 11 electrons, right? But this one will not have 11 electrons because it has lose one electron. So it is 10, right? So it is not equal. Let's come toward this one. It has 11 electrons. This one also have 11 protons, 11 protons and 11 protons. So proton is equal to electron. So it means this one also have 11 electrons and this one also have 11 electrons. So option B is right. Let's see now question number 57. Why do isotopes of the same element have same chemical properties? Chemical properties always depends on the electrons, because I already told you that electrons are the ones that are deciding the properties, the chemical properties, not the physical. Why chemical properties? Because they are actually the one involved in all the chemical reaction, in formation of the bonds, in the breaking of the bonds, whatever. So actually electrons are the one who decide the chemical properties. So for isotopes of the same element, they have same chemical properties. You have to find the answer related to the electron. Where we can find that? They have the same number of electrons in the outer shell. Yes, so option B is right. Okay, and now I will show you all the questions are repeated but with different styles, but they are asking the same question again and again in different papers. You see, which statement explain why isotope of same elements have same chemical properties? So now you see, electrons, I already told, they have the same number of outer shell electrons. So option A is right. So chemical properties are related to electrons. Again, see here, which statement explain why isotope of same element have same chemical properties? Where you can find they have same number of electrons as protons. They have the same electronic configuration. They have different number of neutrons. Neutron is not the one responsible. Proton is not the one responsible. So they have the same number of electrons as protons, right? That is right. They have the same number of electrons as protons, but actually the one which is deciding is they have the same electronic configuration. Actually only the electrons are the one that are deciding the chemical properties, right? So that's why option C is correct. Which statement explain why isotopes of an element have the same chemical reactions, right? You see, again, now they have changed the word chemical properties to chemical reactions, but they have given you the same options. They have different number of neutrons, different number of electrons. They have the same number of outer shell electrons. Yes, outer shell electron is right. Same number. Here they use the word different, so that's why it's not right. So option C is correct. Carbon has, question number 61, carbon has three naturally occurring isotopes, right? Which statement explain why isotopes have the same chemical properties? Again, the same question is repeated. Chemical properties are dependent on electrons. So we have to find the word electron. In this one, we have electron. In this one, we have electron. So now let's read the statements. They have the same number of electrons in the first shell. They have the same number of electrons in the outer shell. Outer shell is the right answer. Of course, they have the same number of electrons in the first shell. But the chemical properties are decided by the outer shell electrons, because always an atom lose the outer shell electrons or it will gain the electrons in the outer shell, right? So outer shell electrons are actually involved in all the chemical reactions or in the bonding. So option B is correct. Two of the isotopes of calcium are represented as calcium this, okay, with a 40 mass, and the other one is 44 with a mass. Which statement explain why these isotopes of calcium have identical chemical properties? See, again, a same question, right? So now see, you have to find the word where we can see the word electron. No word of electron. Here we can see electronic configuration. And here both isotopes have four fully occupied electron shells. So now we have two, right? So why option D is not right? Of course, option B is right. Both isotopes have the electronic configuration of 2882. And if you count it, it will be 20. But this option is not right because they don't have fully occupied electron shell. The last shell is not fully occupied, right? You can see it is just 2. So it's not fully occupied. That's why option D is not right. Option B is right. Question 63. Rubidium has two isotopes. Which statement explain why both isotopes have the same chemical properties? So now you can see here that they are asking this question again and again, and I have collected these questions from different past papers, and you see they are repeatedly asking the same question, but they are just changing the words. And for same chemical properties, you just have to remember the hint, that is electrons, and especially the outer shell electrons, okay? So you can see the same number of outer shell electrons. So option B is right. Carbon has three isotopes. Again, why do all three isotopes have same chemical properties? Again, if you see there, they have the same number of electrons in their outer shell, right? Option B is correct. So, I think I have done this question before. So, okay. Again, question number 65. Iron has atomic number of 26. Which statement explain why these isotopes have the same chemical properties? You see, the question is repeated again and again, but with different examples and with different like question structure. So for same chemical properties, the electron should be same in the outer shell, right? So this option B is again right. They have the same number of electrons in the outer shell. Again, you see, rubidium has two isotopes, which is responsible for same chemical properties. Okay, so they have the same electronic configuration, right? Only in this option we can find the word electron. So option B, again, it is right. Okay, element X has two isotopes. Which statement about these isotopes is correct? Now let's see. They have different chemical properties. Wrong. If they are isotopes, they should have same chemical properties. We don't need to read all. They have the same chemical properties. Yes, that's right. Because they have the same number of outer shell electrons. Yes, again, it's repeated. So option B is right. Question number 68. An isotope of chromium is represented like this. Which statement about an atom of the isotope of chromium is correct? It contains 24 electrons. Yes, that's right, because atomic mass is 24. Atomic number is 24. So atomic number is equal to proton number, and proton number always equal to electron number. So option A is right. Okay, you don't need to read all the options. Question 69. Two naturally occurring isotopes of oxygen are here. Okay, which statement is correct? Both isotopes react with iron to form rust. So this is a chemical process, right? So isotopes have the same chemical properties. It means this option is right. Why not B? Neither isotopes react with iron to form rust. That's wrong. Oxygen always react with the iron to form rust. Third, only oxygen 16 with iron to rust. No, because they have the same chemical properties, so both will react with the iron. Okay, so option A is right. Question number 70. A sample of iridium has relative atomic mass of 192.29. The sample contained two isotopes only. And if you see these two isotopes, okay. So what is the other isotope in the sample? So I have given you a formula here that is how you can find the relative atomic mass of any element. You have to calculate their percentage abundance, okay? You have to first calculate their percentage abundance multiplying with their mass. So if you see, you have two isotopes, right? One is iridium 193 and the other one, can you find here? And another one we don't know, right? So the first isotopes has the percentage abundance of 64.5. So 64.5 multiplied by mass number is 193. Now, see here, this one, what is the other isotopes? So we don't know the percentage abundance, also the mass number, right? So mass number we have to find. How we can find the percentage abundance? 64.5 minus 100. So the answer you will get here, you have to just multiply by mass number of isotopes, but this one we have to calculate. AR is already given here in the formula 192.29, and then you will do all the calculation and the answer will be 191. So for these, because this question usually come in the exam and they want to know about the percentage abundance sometimes, or sometimes they want to know the mass number. So for that, you have to remember this formula. If you remember this formula, it is easy for you to calculate the percentage abundance. Even you can calculate the mass number, and also you can calculate the relative atomic mass. Okay, so you just have to remember this formula. So for this answer, I already have calculated, and the answer is C, 191. A sample of pure iron contains 3 isotopes only. Now we have 3 isotopes. The iron in the sample has a relative atomic mass of 55.9. What is the value of N? Again, you have to find the mass, right? So how you can find the percentage abundance is already given here. So again, you will use the same formula, but now you have to use 3 isotopes, right? And then 3 isotopes, you have to calculate everything and then divide by 100. And then after your answer, whatever it will come, the relative atomic mass is already given here, right? So you have to just do the calculations and then you will get the answer. And the answer, what you will get is option C. You can try it and then you can find that the option C is correct. You will also get 57 answer. Question number 72. The percentage abundance of 3 isotopes in a sample of neon are shown. What is the relative atomic mass AR of this sample? So again, if you want to calculate the AR of this sample, again, you have to use this formula. And then now we have to calculate AR, right? So you just have to use all these 3 isotopes. So 90.48 multiplied by 20. You have to multiply with the mass. 0.27 multiplied by 21. Then plus 9.25 multiplied by 22. So all these calculations you have to do and then divide by 100. Your answer will be 20.19. So that is the right answer. Which statement about isotopes of the same elements are correct? Again, they are the atoms which have the same chemical properties because they have the same number of electrons in the outer shell. Yes, we already have discussed this one, so option 1 is right. They are the atoms which have the same number of electrons and neutrons. No, that's wrong. They have the same number of electrons but not the neutrons, right? So that is wrong. Option number 3, they are the atoms which have the same number of electrons and protons but different number of neutrons. Yes, the number of the neutrons is different. So it means option 1 and 3 is right. So the correct option is B. Okay, so this was all. I have collected all the past paper question from 2016 to 2024. So I will see you in the next video for chapter 3 and we will revise all the past paper questions. Up till then, bye-bye.